The next theorem is g of x is a generating polynomial for a linear chord C of length n if and only if g of x divide 1 plus x raised to n. Okay. If g of x is the generating polynomial, g of x is must divide from 1 plus x raised to n. So by division algorithm, 1 plus x raised to n is equal to, we have h of x into g of x plus r of x. Because g of x is the generating, since g of x is the generating polynomial, so its degree of g of x has minimum degree, and by division algorithm, what degree of r of x is less than degree of g of x is not possible. So r of x must be equal to 0 or a degree r of x must be equal to 0. Okay. So what r of x, if r of x is equal to 0, 1 plus x raised to n is equal to h of x into g of x. That is, g of x is the divisor of 1 plus x raised to n. So that is the theorem. And the corollary is, the generating polynomial g of x for the smallest cyclic chord of length n containing the word v corresponding to the polynomial is v of x is the greatest common divisor of v of x and 1 plus x raised to n. So that is, g of x is the generating polynomial. So g of x is the GCD of v of x and 1 plus x raised to n. That means the common divisor, means the smallest common divisor of v of x and 1 plus x raised to n is what? G of x. Okay. So this is the example. I will discuss later. So next section is discuss about, already g of x is the minimum degree polynomial, and for using generating polynomial we can construct a linear chord C. Okay. And g of x is the divisor of 1 plus x raised to n. If v is the word in C, so corresponding polynomial is v of x, and g of x, that is the minimum polynomial, is the common divisor, is the smallest common divisor of v of x and 1 plus x raised to n. So for using generating polynomial, we can construct a generating matrix and also parity check matrix. Okay. So namukku using polynomial, generating polynomial use ചെയ്തിട്ട് we can make a linear chord, and now in other section, ഇവിടുത്തെ നമ്മൾ ഡിസ്കസ് ചെയ്യാനുള്ള സെക്ഷനിൽ we can construct a generating matrix and also parity check matrix also. Okay. So here this is the, so g of x is the g of x is the generating polynomial, and we say that set g of x, x into g of x, etc., x raised to k minus 1 g of x are the basis elements of C. Okay. And also as a linear set, linearly independent set, and which span C also. Okay. So we already discussed G is generating metric is the non-zero rows in the linear chord. Linear chord ne nammal corresponding matrix aaki convert cheyum. Then a matrix A is reduced into a matrix X. X means a non-zero rows. So consider X is the matrix whose rows are non-zero rows in A. Okay. And G is what? I with X is the generating matrix, and parity check matrix is X with the I. Okay. So similarly, g of x, so generating metric is the metric g of x, x into g of x, etc., x raised to k minus 1 g of x. So this is the generating matrix. Okay. So here C is see the example. C is equal to 0 0 1 0 1 0 0 1 0 1 1 1 is the linear cyclic chord. Generating polynomial for C is g of x is equal to 1 plus x square. Okay. So here n is equal to 4 and k is equal to 2. So here degree of g of x is 2. So n minus k is equal to 2. That means 4 minus k is equal to 2. So k is equal to 2. Okay. So basis elements, what are the basis elements? g of x, x into g of x are the basis elements. So corresponding generating a metric is what? Matrix g of x, x into g of x. That means what is g of x? 1 plus x square. So corresponding word is 1 0 1 0 and x into g of x is x plus x cube. So corresponding word is 0 1 0 1. This is a shifting of this one. Okay. So 1 0 1 0 shifting of this element is what? 0 1 0 1. So this is the generating matrix. So next section is C is the linear chord of length n and the dimension k and g of x is the generating polynomial. The k information digit a0, a1, a2, etc. ak minus 1. A of x is equal to a0 plus a1 x plus etc. ak minus 1 x raised to k minus 1 is called information or message polynomial. So encoding and decoding. We already result into C of x is congruent to a of x into g of x. So a of x is encoded. That is a of x into g of x is equal to c of x. Okay. So here is the example. G of x is equal to 1 plus x cube and n is equal to 7. Okay. And then k is equal to what? 4. So a of x is equal to 1 plus x square be the message polynomial corresponding to the word A1010. So encode. So AX is encoded by C of x is equal to A of x into G of x. So C of x what is A of x? 1 plus x square into 1 plus x cube. That is equal to 1 plus x square plus x raised to 5. So this convert into a word is 1110101. So this is the decoding word. Okay. And okay. So A of x is the message polynomial. Then C of x is equal to A of x into G of x. Okay. So that G of x is the decoded message. This is the reading section, syndrome polynomial. We know that S of x is equal to WH. That is the form of syndrome. Okay. So syndrome polynomial S of x is defined by S of x is equal to W of x into G of x. Assuming G of x has degree n minus k, S of x will have less than n minus k corresponding to the binary word S of length n minus k. And f of x is W of x is equal to C of x into E of x. Okay. Only on the error depend. So this is the reading section. We already proved. So S of x is the syndrome polynomial corresponding to the binary word S. Then S of x is equal to WH. W is the word in H. And H is the parity check matrix. So this is the proof. It's the same. The proof. Discuss just read it. Okay. And this is example also. So here n is equal to 7 and g of x is equal to 1 plus x cube. Then n minus k is equal to 3 and k is equal to 4. Okay. So we find R naught of x. What is R of x is? Ri of x is Ri of x is congruent to x raised to I mod g of x. Okay. So what R naught of x is x raised to 0, that is 1. R1 of x is x raised to 1, that is x. So R1 of x is congruent to x mod g of x, that is x. So corresponding word is 0 1 0. R2 of x is x square. Mod g of x is. Mod g of x is divide. That is x square. So we get these two elements. R6 of x is equal to x raised to 6 mod of g of x is 1 plus x square. Again, we will change same as repetition.